Good evening. This is Marco Stepan de Bera Zeleny for Futurist, Resilient, Renewable, and Sustainable Future Thinking. Today is a great day not only to be alive, but it's a great day to be resilient and work towards sustainability and renewability. There's such a thing as that in energy that we all need, but even more so, there is the importance on the impetus that one could do in a training routine to get stronger, to get more flexibility, and to get more stamina and functionality to one's life. This is important. So, what I wanted to make mention is specifically because I listened to you, Elon Musk, and have a great video. And I was listening and listening some more. And it's great to hear people like yourself and anybody for that matter that is scholastic inside of how they teach. Now, I was thinking a lot of things about your video, but specifically I was thinking about space travel and colonization. And as I'm making my dinner here, as you can see, there's a need for a stove to make some pasta for dinner and some sauce. Clearly, the way to heat it up nowadays is through gas or through a stove, both needing some form of power. Now, and anybody that's watched Matt Damon's show in space, it's a real obvious. You need a way to make things warm. And technically, you got the modern day electron accelerator, your microwave. That's pretty awesome. But here's the thing, when you're in space, as you know, you've been designing spaceships, you're like kind of like this room. When you think about it, you don't have necessarily a large space to work with, but maybe in a very large space station you have more space. But point being, it's not the space inside of space in what you create that is important. It is how do you get energy to make your food over a long period of time. And I'm not talking about like one meal or two meals. I'm talking about if you need to travel well into space, and never mind cryogenic freezing of the individual to wake up one day and then, there's been a lot of science fiction movies about that. I'm talking about being awake, being aware, and having to travel every day deeper and deeper into outer space. Now, clearly, when you're close to the sun is a solar-powered, important thing. But as you go further away from the sun, we all know, look, we're getting further away from the stove. And just imagine you multiply this by hundreds of thousands of kilometers. Your sun over there, which is the stove, can create some good energy. But that's only when you're this close. But when you're this far away, and we're like now way past Venus, the sun is less of a factor. So, what can one do when you're that far away? Well, I started thinking about it. And it makes sense that this would be a good way to get energy further out, because we all know about those cool things called satellites. Well, satellites are great because we look way up there in a space and we're like, hey, wait a second, way up in space, and how do we get a signal in space? I mean, nobody's going to walk up in their ladder and hey, buddy, up in space, what's going on? No, we get a radar signal. And that radar signal beams down like in Scotty on Star Trek. So you get a signal. That's one way. And you can get an imagery. That's awesome. Oh, we get an image from space. That's awesome too. But here's the thing. If you want to harness energy from a sun, like our sun, or another sun, I was thinking, maybe, just maybe, there is some validity to this. To gather energy over long distance in solar rays from deflecting solar rays. And I know that this technology exists, but to what distance and what can be in between a satellite and a relay satellite and multiple satellite of relays? And I said, well, that's the same thing that happens up in our low orbit is there's multiple satellite relays, and that's how Starlink and other things work. But here's the next cool thing. If you were to think about deep space travel, you would think that, wait, why don't we take multiple satellites like we've done for already deep space or organization of collecting data, but then use it to harness energy for when we travel deeper into space. And it does make sense. So that's my feedback today for Elon Musk. And by the way, you've got a whole team of different companies inside of US astronomy and space work. So NASA and the European Space Union, comprised of many different awesome organizations, the German Space Agency. You've got the Russians you can work. If you think about it, space, the next frontier, it's like an intergalactic important race together, because together everybody achieves more. And if you think about it, everybody on the planet Earth, in order to evolve, we're going to eventually run out of sunshine. And the sunshine will do what every red giant does. It'll become huge and envelop the Earth. We all know this. So traveling out there to the stars is important. And many people say, well, that's so far ahead. Well, you can't in the last second say, hey, let's go out into space and take our chances on where we end up. No. So important. 929, prime left, prime right, even right center, nothing goes to the left side. And on 20 time summation, which is all senses are on, it takes time for me to boil this pot of water, but not as long when I put a lid on it. Or, chemistry is way important. Not as long as if I were to put in some salt. So these small cool details is what I also thought, and especially I love science shows. And if you think about it, space inside of the infinite potential to survive in space, there's a lot of need for chemistry and chemistry lessons with how to heat up things, which is already being done. And there's tons of cool stuff. But I think that was way important of a message to talk to the different space agencies and work out a way to be able to take the existing satellite technology and utilize that inside of a space exploration and deep space exploration program. Now, I also have something with my eye here, and it gets me thinking about another cool profession, and the optometry profession. And I've got this, what's called a cor lesion. It sounds Italian, doesn't it? It sounds like some pasta in my eye, which is basically a duct in my eye that's been backing up with oil. And as I put a compress on it, it heats that oil, and it's been slowly draining. It's a long process. Apparently I have a lot of oil in my eye. Maybe it's because the circulation in my building, got our little fan here, which is important to have on, and that pushes the air, and I could turn my heater on, but I'm saving on electricity in a good way. And you can see the windows open here to have fresh air circulating in through here. So no heat on, but I'm circulating that air and pushing it around. And that's another important thing, is the air quality inside of buildings, definitely inside of what will be Mars without an atmosphere. That's a very big consideration. And you watch Total Recall once, you'll know how important, with Arnold Schwarzenegger, the movie and science fiction is to real applicable science present. Isn't that great? I mean, science fiction not for so long ago did Arnold Schwarzenegger travel way up onto Mars, and so now that's a cool reality. And the importance on increasing the daily realities of what we all need here on Earth. Air is huge. Air quality. So if you look at what you were talking about in cost to travel into space, I look at something more important, quotient. The costs are involved in everything. But big governments with big spending have big initiatives to travel everywhere, so you better believe governments will take care of the bill. They need to, for the humanity's survival. And they've often rationalized this way, and they should. In addition to getting up into space, think about the air quality is way important. So the quotient of total air, healthy molecules, no thank you, to your breathing apparatus. So as you go up into space, everybody knows you need to have good air quality, and that's why the helmet was made. So the astronaut's helmet. Then in addition to an astronaut's helmet, you would have the need to take off your helmet and be inside of a room or inside of a building. And how do you generate oxygen on a planet that doesn't have an atmosphere? And an atmosphere keeps oxygen in. And this is the big part of why it works on Earth. Why do we have natural oxygen in our atmosphere to begin with? And we all know about the ceiling, and we know about microwave air. We know about this climate. All that's knowledge that hopefully everybody should know by now. Point is that when you're on Mars and you don't have an atmosphere and everything is radiated into space, how do you create potentially an atmosphere? So I thought about it, and a lot of people in the industry have thought about it, and what makes sense to me, without having done an experiment, but just the most sensible thing is to create a Earth-like condition without having to do too much more than what we see on Earth. And so terraforming is something that they do on Earth, and we have like the simulators here on Earth, but terraforming to Mars, and I know you've talked about and discussed it, but I honestly think it's one of the most important things to not just Mars, and this is the big point, but to any planet that needs to become more habitable to what we call a Goldilocks zone. And the Goldilocks zone, the three bears, awesome. It has to be perfect with water, perfect with air, and the rest of the important parts of life will be able to take place. But air is huge, and so is water. Unmistakable. So with inside of traveling into space, terraforming, and now with your rocket ship design, getting as much materials up there is one thing. But the next thing is, wait a second, our Earth coalesced from small bodies coming together, and water was a part of it. So yes, comets and or places in space, I think, would be a cool idea to start harvesting very large meteors to bring some of that important usable water, and I'm sure there's some very big large bodies traveling through space and figuring out how to move those. And think about it in terms of, you've seen all the shows about don't want to close my eyes, I don't want to fall asleep because I miss you, babe, and I don't want to miss the Aerosmith, awesome music from those great movies that have to deal with large celestial bodies hurtling towards Earth and different case scenarios, just like any business issue, to figure out, like in the Waldorf school. And how do you get these very large comets and or very large rocks onto Mars to be able to harvest some of that water, which has already happened, and we all know it. I think that's an important industrial, what I would call real case for harvesting of water to bring from there instead of just from the Earth. I mean, it makes sense. It's already in space, and it makes sense to build the technology to move it. I mean, think about space. Space is cool. Like, once you start moving something in space, it keeps moving. Gravity is different. We all know that. So how do you harness it and building the technology to move the utilizable water in space to get it to Mars? I think it's important. Part of not just Mars, but any sort of space-borne civilization. So that is my feedback today for you, Elon Musk, as well as NASA and all of the different important space exploration, space engineering programs, and all you potential future engineers. How do you build engineering to harvest the important, very important water already in space? It makes sense. Ooh, and then also, how do you terraform to find whatever existing water, not oil? That's not, I mean, potentially you could find oil too, I'm sure, in space. But how could you harvest the important water to be a part of an atmosphere? An important concern, and definitely a very important planning, investing part of engineering for space colonization. This is Mark Zeleny reporting live from the capital city of Canada, Ottawa, on my forward thinking for resilience, renewability, and sustainability, not just on Earth, but also in space. Have a great evening, everyone.